In this lecture, we will learn how to perform derivation using context-free grammars. You can see there are two different processes using which we can derive something using the context-free grammar. Means ultimately our motive is to derive some strings, okay, from certain variables. Okay, so what are the two different approaches present? One is called recursive inference and the other is called derivation. We will see the two forms using an example. The concept will be clearer then. Let us first focus what recursive inference says. Here we will take strings known to be in the language of each of the variables of the body, concatenate them in the proper order with any terminal appearing in the body and infer that the resulting strings in the language of the variable in the head. What is the meaning of it? Firstly, we will consider any variable, right? We will keep that variable there, and whatever the production rules is given, from there we will replace it and keep on replacing there so that the resulting string will be to that language value. Here in case of derivation, what we will use, instead of just recursive calling, we will keep on expanding the start symbol. We will start with the start symbol and then keep on expanding it. We will replace one variable with some production rules present. Whatever the string we need to be generated accordingly, we will use the derivation. This derivation rule is most oftenly used other than the recursive inference. You will see the derivation is much more easier to understand, or not easier, but derivation is most oftenly used, right? So we can see that derivation, we will use derivation other than recursive inference in most of the cases. Okay. First see recursive, the concept of recursive inference for this example. This example, what it is doing, what are the variables present, e and I, fine, and what are the terminals are there, a, b, 0, 1, in this fashion. These are the terminals present. So if we have to follow recursive inference, these are the rules we have to follow. What it is doing, line 1 says that we can infer string a is in the language for I by using the production 5. So if we have to infer the string a, how can we do it? We have to use I to a, otherwise it is not possible. And how to generate I? If we have to follow the total procedure, we have to first start with e, then from e to I we will move to I, then from I we will move to a. Okay, line 2 to 4 says that we can infer that B00 as an identifier by using the production 6 once to get the B. So if you follow from 2 to 4, you can see that first 2 is generating B using I, and that comes under production rule 6, and then your B0 again from I using a production rule 9, and string use is of 2, means you can see that in 2 what is already being generated, that is B. And if we now use rule number 9, you can see there the rule is from I we can move to I0. So again if we use rule 6 to replace the I with B, then ultimately B0 can be formed. So these are the ways of recursive inference. Just follow the table and you can just learn the rules whatever written in the left hand side of the slide. You can understand it. In the next slide this explanation goes on. Let us say for lines 5 and 6, what 5 and 6 is doing, 5 has to generate a, so from e it can generate directly a, and how? Because from e we can generate I, and from I we can generate a. So ultimately we are using your roll number production 1, and string we are using 1. Why you are using string 1? Because here already we have seen in the table that from I we can derive a. So if we can derive I from e and can replace I with a, then our job will be done. So in this fashion recursive inference works. Okay, next the other descriptions are given up to the total line number 9 how we have generated it. Just follow the slides, the concept will be clearer. Okay, now this process of derivation, how derivation acts. The process of deriving strings by applying productions from head to body requires the definition of new relation symbol. This one, what is the meaning of this? From head to body means from start symbol to its body. So whenever we will see this arrow means what? From one particular symbol we can generate this. So that arrow means from the, by replacing this variable we can generate these terminals or the combination of terminals and variables. Now suppose this is the grammar given, the standard definition of CFG, that is VTPS, and we are considering alpha a beta b a string of terminals and variables with a variable. So here you can easily say that in this string alpha a and beta only one variable is present, that is a. So our job will be to replace this one. Fine. So alpha and beta are the strings in variable union terminal obviously. So from variables and ultimately we are getting the terminal, so it is belonging to this one, and a is the only in V. A cannot be the combination of variable and terminal like alpha and beta, because alpha and beta and ultimately we will generate it from some variables. That's why alpha and beta will be a string from the combination of two sets, that is variable and terminals. Okay. Now if we have a production say a to gamma in G, then can you say that we can replace alpha a beta to alpha gamma b? Obviously, because in case of variable we have just placed the gamma. So this is the rule of derivation. What we will most often, or you can say in everywhere, we will use this concept of derivation. It is much more in use other than the previous one. Okay, now how to do this in form of basis or induction if we follow the rules. So what is the basis? For any string alpha of terminals and variables, we can say that alpha generates alpha, that is any string derives itself. Okay, please do not get confused that here alpha is a terminal, how it can generate alpha again. We are not saying that. If we consider that any language is having only one symbol, we have to generate say a. So from any variable it will generate only a. So that is what the basis is, means we have to consider the minimal basis as we already seen. So considering the basis as like this. Okay. Now next, if we have to follow the induction, please listen carefully that if alpha derives beta and beta derives gamma, then we can say alpha derives gamma, because if we derive beta from alpha and if we replace gamma in the place of beta, then this will come, transitivity rule. Okay, that is if alpha can become beta by 0 or more steps, that's why the star is given there. Okay, so means we are just considering the method of induction. We don't know after how many steps or after how applying how many number of production rules ultimately this will generate. So we are giving star. It may be, it may come in 0 step, it may come in 1 step, 2 steps, and so on. And put these are the another way of representation. Put another way, that is if alpha beta, there is a means that there is a sequence of strings gamma 1 gamma 2 gamma n for some n greater than equals to 1, means you can replace with many number of gammas. It can be, we have represented it with gamma 1 gamma 2 gamma 3, but it can be any terminal symbol, say a b c d or 0 1 a b, like this. Okay, it can be replaced with any kind of terminal symbols. For n equals to greater than 1 means the size of the length of the string may be 1, maybe more than that. Okay, so such that what will happen, alpha equals to gamma 1. Why? Because the first terminal symbol is gamma 1, means this is our basis, that if we have only one terminal symbol we can generate like this. And beta means the number of steps we have applied on alpha to generate beta, so it can be gamma n, it can be anything, right? Gamma 2 gamma 3 gamma 4, or the combination of all. So whatever the number of times we have applied these rules, it is not fixed, that's why I have kept star, so it can be any value. Okay, so this is the method of induction, following which we have already proven that gamma I equals to, can derive gamma I plus 1, means from 1 to a moving to the next. Okay, Now see, this will be very much more clearer to you because we have used an example here. Here we have to generate the string a star bracket a plus b00. Please remember the grammar that we have defined earlier. Using that grammar we will generate this. Okay. Now you can say that why we have replaced the e with e star e, not e plus e, and so on. But here we are focusing on one procedure, that we are dividing it into two parts, a star then a plus b double zero. So star should come in between. That's why I have replaced e with e star e. Then we have to bring a before star. That's why we have replaced it with I, because there is one rule present, namely I derives a. That's why we have replaced the first e with I, and then I with e. Okay. Now in place of e we have to bring a notation which is having a bracket, open bracket and a close bracket, because you can see in the string there is an open bracket and a close bracket. We have to bring that. In between, what we have to bring? E plus e, because first e again we will replace with I, then it will be replaced with a, and then again e will replaced with I will replace with I0, and then it will replace with again I will replace with I0, and in place of I we will place b. Okay, you can see, follow the grammars defined there and you can easily derive this one. So you can see here always that variables are being replaced with the production rules, means we are deriving some terminals from the variable given. So that's why this is called the process of derivation. Okay, so this is the total procedure written here, how we have generated that grammar. Please have a look at it. I have already explained there. Okay, this is a more formal definition. We can use this relationship to condense the derivation. So if we have to replace it formally, that from e we can derive e star e following any number of derivations. Following any number of times e can be replaced to find the e star e. It can be one for in the first replacement, it can be okay, or in n number of replacements it can be generated. So this is the formal way in which we have derived. This is the formal definition of that derivation. Okay, now we will see two kinds of derivation. One is leftmost derivation, other is rightmost derivation. See, here we are writing lm means nothing, leftmost derivation. What we will do here, if you look at the procedure of derivation, you will always see that the replacement is being carried out with the leftmost variable, not with the rightmost variable. If we follow from the first step, see, first e, from e we have formed e star e, but now it is mandatory to replace the leftmost e. In case of leftmost derivation, you cannot replace the right one. So first see, the e has been replaced with I, then I has been replaced with a. Now it is done. A cannot be replaced with anything because a is terminal, not variable. Now we are having only one variable a star e, so we will replace e with bracket e. Now again within bracket we have written e plus e, so which e will get replaced? The first one within the bracket. In this fashion you can generate the same string which we have generated earlier. Now if we have to see the reverse one, that is rightmost derivation, you will just do the reverse one. Ultimately you can generate the same grammar in the following the same fashion. Why we are using these two kinds of derivation, leftmost and rightmost? Because when you will move to your, in the next semester you will learn compiler design, you will see in some of the parsers they use this rightmost derivation. Some of the parsers are there which they will use rightmost derivation and to find out, to generate the strings or to make the compiler work. Okay, so this kind two derivations are available. Some parsers are there which they will use the top rightmost, and some will use the leftmost. There are many other choices, reverse of rightmost. Fine, keep it for now. When we will learn compiler design, the concepts will be more clearer. Okay, so this is the end of today's class, and in the next class we will just learn what is the language for this grammar. As we have seen in case of our finite automata, the language was regular language. Here in case of your context free grammar. The language is called context free language. We will see in our next class. Thank you.